Okay, this is the first example. This is easy. We compute the triple integral in the region R of the integral function is x dv, and the region R is bounded by the plane x plus y plus c equal 1 and in the first octave. Okay, this is the sketch in 3D, roughly sketch in 3D. Look, es si suppose que y and c is 0, x equal 1, this point. Suppose que intercept x and y are 0, c is equal 1, that one. And likewise, suppose que x and c is 0, y 1, at this point. To see much better, I do in GeoGebra to see the region R. Okay, the region R is 3-dimensional. It's the tetrahedron formed by first octave and the plane x plus y plus c equal 1. Now you see more clear, right, in 3D. Okay, to compute the triple integral, we can apply different methods. For example, we apply one method that's called C simple. What means C simple? Okay, C simple means que you suppose que we have two surfaces parallel to the z-axis. So, for example, in this case, I go from, this is a symbolic way to indicate that. I go to the c equals 0, to the c equal the c of the plane. So c is in between 0 and the c of the plane, que you isolate here is 1 minus y minus x. This is the walk of the plane here, here, to this, to this. Now, okay, this is one possibility. Now, you projecting onto the x, o sea, the projection. Now, C simply indicates that the projection is onto x, y plane. Projection, P, projection. Entonces, en x, y plane, we have something like let me see. We have something like that. Is okay. Wait a second. Okay, ready. This is okay. This is, I suppose this is x-axis. This is y-axis. This is 2D. This is the projection. This is here, how far. Okay. Now here you perform a double integral. Exactly what we are doing before. For example, I make a decision to integrate in this direction, y direction first, and after you expand it in x direction. Okay, so the conclusion is this is the z direction, c first, okay, or different way. There are different alternatives, you select the best way. Okay, let me set up the integral. Okay, no here. Okay. This integral is equal triple integral. We have 1, 2, and 3 layers. X, so I make a decision to integrate first with respect to the c. And c go from 0 to the walk of the plane, que is 1 minus y minus x. I did the first part. Now I make a decision to integrate with respect to y, because I want, not necessarily like that, but you can integrate in other direction, but no, I make a decision to integrate. Entonces, when you integrate with respect to y, okay, y is bounded. Let me see where. Okay. Okay. C was bounded between 0 and 1 minus y minus x. Now, remember the equation is x plus y plus c equal 1. Alright, in 2D, in which c is 0, we have x plus y equal 1. Therefore, y is equal 1 minus x. Okay, it's this line. So y go from 0 to this line. From 0 to this line is 1 minus x. And finally, we extend it from 0 to 1, que is x value. Okay, and this is the setup for the triple integral. Wait, I forgot the x here. The x is this integral, the integral dy is this integral, and this is this integral. It's important, notice que in the first integral, que is the first layer, we have two variables. In the second, we have only one, and in the last one, we have no variable, we have only numerical value. To compute this, is exactly the same of the double integral. Iterate integral. You integrate first with respect to x separately if you want, and so on. Okay. I do not recommend do by hand. I'm using calculator. Let me explain it how we can use a calculator. And there are many ways. You can use it Wolfram Alpha, or we can use it Desmos or GeoGebra, but I prefer Desmos. Let me show you how. Okay, this is the way to set out the triple integral in Desmos. For example, you go to the keyboard, you select functions, miscellaneous function, and you select integral. But you separate the integral using parentheses. Look. You type in this integral first, open parentheses. This is, okay, we are doing like that. So the example we are doing in this way. You open this integral from 0 to 1, open parentheses. This is dx. Now this layer is dy, and this is dc. Though the beauty is that we can do in different order, and the answer is the same. Let me try to do another order. Suppose I change the order of the integral. Yeah, I using, for example, y simple. Y simple. Y simple is look, is from 0 to the walk of the plane, like that. Okay, now y, que is the first layer, now go from 0 to the 1 minus c minus x. Where come from this? Well, this is, remember, x plus y plus c equal 1. You solve for y. Y is equal 1 minus c minus x. Okay, we navigate in this direction because I want. This is another possibility. Now you project this is y simple. You project it onto the xz plane. To the representation in 2D is like that. So you integration, for example, you make a decision to integration here in c for second from 0. Suppose y is 0, so y is 0 is x plus c equal 1 because y was 0. And c is equal 1 minus x. This is the second limit, 1 minus x. I did that in that direction. Finally, extending in both directions from 0 to 1. X is the last one. Similarly, we are using in another direction, we are doing in another direction. Okay, now suppose you make a decision to do the integration first using x simple. Remember, x simple, the projection is in the y-c axis. Now This is not x anymore, es y. Es y. Okay, entonces the integration in the 3-dimension first is like that. Go from 0 to the 1 minus y minus c, que es the value of the x when you isolate x in the equation of the plane. Now let's go to the 2D. In 2D, you make a decision integration first with respect to the z. The z go, so remember, x plus y plus c equal 1. But x is 0. Entonces y plus c equal 1. C is equal 1 minus y. From 0 to 1 minus y. And finally, we extend in y from 0 to 1. Get the last layer 0. And you can see, okay, we get the same result in this one. Okay, entonces, summarize the idea. In triple integral, you need to do the sketch in 3D, and also 1 or 2 sketch, depending, to see much better in 2D, because you are solving first the first layer, que es in 3D, and finally you convert the problem in double integral. This is basically 2D is double integral. Okay, let's practice.